This video is about parametric differentiation, wherein you have, let's say, one function y, which is a differentiable function of t, a parameter t, and x is also a differentiable function of that same parameter t. So this t acts as a parameter for both of these functions. So that's where the terminology parametric stems from. So you can consider this y as a function of x and talk about its derivative with respect to x. So you can talk about derivative of y with respect to x, and the way to calculate the derivative of y with respect to x is like this. Now here you don't have y as a function of x, so you can't do that directly. But you can do this via the parameter in this fashion. What you do is you find the derivative of y with respect to t, because y is a differentiable function of t, and you also find the derivative of x with respect to t, because x is a differentiable function of t. So you find dx by dt, and then you take the ratio of that. Now mind you, it is not correct to say that this dt gets cancelled and therefore what is left is dy by dx. That is good intuition. That is a good thing to remember this technique, but that is not technically true, because this dy by dt is a symbol for the derivative of y with respect to t, and this dx by dt is the symbol for the derivative of x with respect to t. So these are not numbers. Dx, dt, dy, dt, these are not numbers which can be cancelled. These are symbols. So the parametric differentiation says that you find the derivative of y with respect to t, find the derivative of x with respect to t, and then the quotient that you get is what is the derivative of y with respect to x. And of course, this is valid only when dx by dt is non-zero, because dividing by 0 is not valid. So I'll demonstrate this with an example wherein, let's say we have a function y, which is 5 raised to t. So it's a differentiable function of t, of course, and x is equal to log of t, which is again a differentiable function of t. So I can talk about what dy by dx will look like here in this case. So first, for that, I'll need to find what dy by dt is. So I'll need to find dy by dt, which is nothing but the derivative of this 5 raised to t with respect to t. And again, it's a very standard derivative. It's a derivative of the form a raised to t. So that is nothing but 5 raised to t into log 5, the very first standard derivative, one of the first standard derivatives that we looked at. And next we calculate the derivative of x with respect to t. So derivative of x with respect to t. The derivative of log t with respect to t is just 1 by t. This is again one of the standard derivatives. You can refer the previous videos in case you don't know where this comes from. So the final dy by dx is nothing but, if I were to do it here, dy by dx is nothing but the ratio of these two derivatives that we have got, the quotient of these two derivatives. So it is nothing but 5 raised to t log 5 divided by 1 by t. Now, if I were to simplify this further, dividing by 1 by t is as good as just multiplying by t. So this would come out to be, I can write the t up front. So this would be t times 5 raised to t times log of 5. So yeah, that's what the derivative of y is with respect to x, and it's okay if it is in terms of t, because if t is known, then automatically x and y are both known. So yeah, this is how calculate the parametric derivative.